Hello everyone, I hope everybody is fine. In this lecture we want to talk about the theoretical definition of the derivative of a function. So this is the first time we want to talk about something called derivative. So the derivative of a function f at a number a, denoted by f prime of a, is given by the formula f prime of a equals limit of this quotient f at a plus h minus f at a over h when h approaches 0. So if you grab this quotient and find its limit when h approaches 0, then you end up with a number because it's a limit after all. So the answer to a limit question oftentimes is a number. That number would be actually the derivative of the function at that number a. With a numerical example, we can understand this better. And I think in a separate lecture, I will talk about the geometric interpretation of the derivative, which represents the slope of a tangent line. But that will be a separate lecture for itself. So oftentimes the question says, using the first principles, find the derivative of such and such function at such and such number. So whenever you see this terminology, using first principles, it means you have to use the theoretical definition of the derivative, which means you have to use this formula. That is, calculate this limit. There are formulas that we will learn in future. They're called differentiation rules that you can easily, and maybe in one line, find the derivative of this function. But when the question says using first principles, you cannot use those differentiation rules or shortcut methods. You have to use the limit formula. So we are going to set this up. We're going to say what we're trying to find is f prime, and this is like a notation for the derivative of a function. So when we say f prime, it means the derivative of the function f. F prime at 10, this is what we want to find actually. So the value of a is 10 here, because the question says find the derivative of f of x at x equals 10. Okay, so using the formula, it's going to be limit of f at 10 plus h minus f at 10 all over h when h approaches 0. So we set up the limit using the formula, and all we need to do is to find this limit right now. So this is limit of f at 10 plus h. Now f of x is a square root function, so it's going to be square root of 10 plus h minus 9 minus square root of 10 minus 9, because that's what f at 10 is. You substitute 10 for x all over h when h approaches 0. If you simplify this, it's going to be limit of square root of 1 plus h minus simply 1 over h when h approaches 0. But the thing is that if h approaches 0, both the numerator and the denominator approach 0, which means that we end up with the so-called indeterminate form. So we need to use one of the techniques of limit computation that we have learned in the past, and frankly we have learned so many of them, to find this limit. So we are going to use the rationalizing technique here, and you know how to deal with these kind of questions. So I'm going to multiply by the conjugate radical of the numerator. So both the numerator and the denominator are multiplied by square root of 1 plus h plus 1 when h approaches 0. And the purpose is to come up with the product in the numerator where the radical would be eliminated using difference of squares. This is a minus b times a plus b, whose answer is a squared minus b squared. So we end up with limit of 1 plus h minus 1 squared all over h times the radical expression. So continuing, 1 minus 1 cancel out each other. We are left with h in the top, h in the bottom. We can certainly cancel them out in the next step. So we have 1 over square root of 1 plus h plus 1 when h approaches 0. And in this case, the answer would be 1 over 2. So we can say, therefore, f prime at 10 equals 1/2. The derivative of this function, the square root function, at x equals 10 is equal to 1/2. And as I said, the geometric interpretation of that would be the slope of the tangent line at a point on the curve whose x coordinate is 10, and that is 1/2. Okay, so I think it's clear. Now, instead of finding the derivative of a function at a particular value, at a particular x value, in this case it was x equals 10, instead of finding f prime at a, we can actually find the derivative of a function as a function. So if that a, which is like 10 in this case, if we consider that like actually any x value, then we end up with f prime of x, which would be limit of f of x plus h minus f of x over h when h approaches 0. And we end up with a formula very similar, but this one gives us the derivative of function as a function, okay? So we will not end up with a number as the answer. In this case, the answer was, so I write here answer, the answer is a number. But in this case, the answer is a function. So if I solve an example here, I will not end up with 1/2. I will not end up with like a constant number as the derivative of the function. I will end up with a function. So the derivative of the function itself happens to be a function. Okay, so we have a cubic function here, and we want to find f prime of x. Okay, not f prime at a particular number, but f prime of x in general as a function. So again, we're going to say f prime of x equals limit of f at x plus h minus f of x. We are going to do the substitution. So f at x plus h would be x plus h cubed minus 2 times x plus h plus 1, and then minus f of x itself, which is x cubed plus 2x minus 1 all over h when h approaches 0. Okay, so there's a little room there. Okay, so that is the limit we need to calculate. So we'll see if we can simplify. X plus h all cubed, if you multiply x plus h 3 times by itself, expanding, simplifying, collecting like terms, you will end up with this answer. X cubed plus h cubed plus 3x squared h plus 3xh squared, and then minus 2x minus 2h plus 1, I'm doing the expansion, and then we have negative x cubed plus 2x and then minus 1 all over h. So this is the next line. Okay, so let's see if we can simplify this. I say x cubed and minus x cubed cancel out each other. So far, I would say h cubed is left. 3x squared h is left, so 3x squared h. And then we have 3xh squared, because 2x and minus 2x cancel out each other, so plus 3xh squared. And then negative 2h is also left. And then we have plus 1 minus 1, which cancel out each other. So we end up with, yes, we end up with whatever we end up with. H approaches 0. So after collecting like terms and simplifying, that's what we get. Now you may notice that h is a common factor in the numerator. We can factor it out. So we get plus 3xh minus 2 all over h when h approaches 0. But then h and h cancel out each other. So we get limit of h squared plus 3x squared plus 3xh minus 2 when h approaches 0. And the denominator is just 1. Now if h approaches 0, all those terms including h will approach 0. And we end up with 3x squared minus 2. And this is actually the final answer I will write y prime here. Y prime or f prime of x is the same thing. They both represent the derivative of the function. So if the function is a cubic function, x cubed minus 2x plus 1, its derivative as a function is a quadratic function, and that happens to be 3x squared minus 2. We ended up with a function as promised before. We didn't end up with a number. Okay, so that was example number 2. And here we have another example. It says find f prime of x, again, if f of x is this rational function. So here we had cubic function, this was rational function, this was square root function before. So let's see how we can find. We're going to say y prime or f prime of x, doesn't matter, equals limit of 3 over x plus h minus 4 minus f of x, which is 3 over x minus 4. I don't have room, that's why I didn't write the formula, but I suggest every single time you always write the formula down first and then do the substitution. I didn't have room, that's why I didn't rewrite it. So now, if you sub in 0 for h using direct substitution method, you see that it's indeterminate form, 0 over 0. Even before it was like that. So now we end up with limit of, we find the lowest common denominator, x plus h minus 4 times x minus 4. So it's going to be 3 times x minus 4 minus 3 times x plus h minus 4. Okay. And then all over h when h approaches 0. We have to simplify. We are using the simplifying technique. So we get 3x minus 12 minus 3x minus 3h plus 12 in the numerator. In the denominator, we get h times x minus 4, x plus h minus 4, and h approaches 0. So 12 minus 12 cancel out each other in the numerator, 3x minus 3h cancel out. So we end up with only 3h, or negative 3h, left over in the top. So negative 3h is what is left in the numerator. In the denominator, we have h, x minus 4, x plus h minus 4, as h approaches 0. So now h over h is 1, they cancel out each other. We end up with limit of only negative 3 in the numerator, and in the bottom, x minus 4 times x minus 4 plus h. And if h approaches 0, clearly x minus 4 plus h would approach x minus 4 itself. So the denominator would be x minus 4 all squared, and the numerator would be negative 3. And this is the final answer. Y prime, the derivative of the function, of this rational function, would be negative 3 over x minus 4 all squared. That would be the final answer. Okay, so I give you 3 examples, and we will talk about derivatives more. And I should say, starting today, in fact, there is no question in calculus in future that we will not talk about derivatives. It's like very fundamental idea. Thank you for your attention and keep practicing.